We've been working on identifying proportional relationships in charts. So there are two charts here. I display some data. There's two competing cab companies. Cab company number one charges an initial fee of $4 and then $1 for each additional mile. So when you get into the cab, it's $4, and after 1 mile, it would be 4 plus 1, which would be 5. So then $6 for 2 miles and $7 for 3 miles. Cab company number two charges no initial fee, but charges a much pricier $3 per mile. So initially no fee, 1 mile would be $3, 2 miles would be $6, and 3 miles would be $9. To tell which one is proportional, we would look for a constant that we can multiply by the number of miles to give us the dollar amount. Or we can find the unit rate by taking the miles and dividing it by the dollar amount and making sure all the unit rates are the same. If you look at cab number one, we can see that if you're looking at the row where you have 1 mile, we would have to multiply 1 times 5 to give us 5. But then looking at the next row, we would have, in order for it to be proportional, we would have to multiply by 5 again, and 2 times 5 is not 6. So cab number one is non-proportional. If you look at cab number two, we can see that in row 1, there is 1 mile and $3, so we could multiply by 3. And then checking each additional row, 0 times 3 gives us 0, 2 times 3 gives us 6, and 3 times 3 gives us 9. So cab number two's miles to their cost is proportional. This lesson is based on what does it look like when we graph these, and what commonalities do we see with proportional relationships. So let's graph cab number one on the set of axes. At 0 miles, it's $4. So let's label these. This will be the miles on the x-axis and the cost on the y-axis. So cab number 1, 0, 4, 1, 5, 2, 6, 3, 7. And we can draw a straight line through it. And then let's move to cab number 2. At 0 miles, it costs no money. 1 mile will cost $3. 2 miles will cost 6. And 3 miles will cost 9. And we can glean a lot of information from the chart. We can see that if you're only going 1 mile down the road, it would be cheaper to take cab number 2. But if you're going a long distance, it's going to be much better to take cab number 1, because at first it's a little more, but then it's much cheaper the further you go. And more importantly, cab 2 is proportional, and we found out from several examples today that we can tell by a graph if something is proportional by the fact of it starting at the origin and being a straight line when graphed. If it is not a straight line, or it does not start at the origin, it is not proportional. And the reason for starting at the origin is because we need a constant. 0 times a number will always be 0, no matter what the number is. So this is not proportional and does not start at 0, because there's nothing times 0 to give us 4. That's not possible. So it always has to start at the point 0, 0, and it always has to be a straight line to be a proportional relationship.